Hello YouTubers, welcome back to this electrical distributor tutorial. This is tutorial 2.2, following up from the previous tutorial. Here we have an aluminum wire which is 7.5 meter long and is connected in parallel with a copper wire 6 meter long. When a current of 5 amps is passed through the combination, it is found that the current in the aluminum wire is 3 amps. The diameter of the aluminum wire is 1 millimeter. Then they want us to determine the diameter of copper wire. If the resistivity of the copper is 0,0117 micronewton meter and that of the aluminum is 0.028 micronewton meter. Now, the important things here to note is when you're reading, you must visualize because it's an electrical circuit distribution. So you need to visualize the circuit as you're reading and draw it. So we have an aluminum wire and a copper wire, which are both in parallel. Then there is a current that's going in and coming out, which is a current of 5 amps. Now that current is splitting into two as a parallel branch and mixing up right at the end. So the aluminum wire is 7.5 meters, the copper is 6 meters. We draw the circuit. The aluminum cable is said to have a current of 3 amps. The total current is 5 amps. Now if we have a 5 amps coming in here, 3 amps going there, 5 amps coming out, then there must be a 2 amps on the copper cable. So we close our circuit. This is a voltage source. We don't know what it is, but we just say it's a voltage source. It could be a current source or anything, but we are just dealing with the 5 amps current that's going in. Now, from here, what do we do? First, we need to see what do we have from the circuit. We have a diameter of the aluminum, which is 1 millimeter, is given to us. So we can use the diameter of the aluminum to find the area. And from the area, we can calculate the resistance of the aluminum using this formula here, as we've seen from the previous tutorial. Now, according to the area of a circle formula, it is given by pi times the diameter squared over 4. Now, if we plot all the values, we're going to have the area of the aluminum is equal to 0,785 times 10 to the power minus 6 meter square, because we replace the diameter, which is 1 millimeter square, which is square. It gave us 10 to the power minus 6 meter square, because milli, which is 10 to the power minus 3 square, give us 10 to the power minus 6, and meter, which is squared, give us meter square. The overall, we got 0.785 micrometer square as the area of the aluminum wire. Now, from there, we can then deduce to calculate the resistances. We got now the area. Now, the resistance, by replacing the value of the resistivity of the aluminum, which is 0.028, and then the length of the cable, which is 7.5 over the area, that gives us a resistance of 0.267 ohm. That is the resistance of this cable here, the aluminum cable. Now, which is starting to unlock our circuit. We know this is a resistance that gives us the 3 amps. Now, what is a resistance that gives us 2 amps? Now easily we can use the current divider formula to find this resistance. Because if we find this resistance here, we can use this formula also to find the area. If we find the area, we can then use this formula here to find the diameter. That's how you solve this thing. Very quick and easy. So we go ahead. What do we do then? We use our current divider formula, using the resistance of the aluminum to find the resistor of the copper. Now the current divider formula gives us this. Now from here we can be able to determine this resistance since we have all of this. Where is our circuit? Let's check for our circuit. Here is our circuit. What do we have? We know that the copper cable got a current of 2 amp, which is I copper. That's ICU. Then the total current is 5 amps. This resistance, we already calculated it, which is 0.267. Now, from here, this becomes just a simple algebra manipulation. So we replace the value. ICU, which is 2 amps. The aluminum copper resistance. The aluminum cable resistance. Then the total current. And RCU, which is the unknown. We manipulate, we find that RCU equal to 0.4 ohm. That's the resistance of the copper cable. We then use this formula to find the area. So we manipulate the formula. By manipulating the formula, we just transverse. Then we replace, we find the area of the copper cable, which is now 0.255 micrometer square. Since we have now the area of the copper cable, we can use the same formula that we used to calculate the area of the aluminum cable. Now by transforming that formula to calculate the diameter of the copper cable. From this formula, it get to this one. You can see that the diameter, so the 4, so if you send the 4 this side, then the pi come down, then the diameter square will be able to square now everything, raise the square root on this one, and then the 4 will come out of the square, then you get this formula here. Then from there you can then replace your area, which is 0.255, 10 to the power minus 6, and your pi. That gives us a value of 0.569 millimeter. This is how you solve this type of problem. Again, it's not very difficult. You just have to concentrate, visualize your circuit, deal with the basics, the details of the current flow, all the laws, ohm laws, take into account current divider rule, very important law, and you'll be able, by using your physics formula, and able to find the diameter of the copper cable as requested by the exercise. Thank you again, once again, for following. Please tune in for the upcoming tutorial. Don't forget to hit the like button and share. You can subscribe and hit the bell to always be in the know when a new video is uploaded. Thank you once again. Cheers.